Hello everyone. Today we are going to study some questions. Today we are going to practice some questions related to some basic concepts of chemistry. So let's start. First of all, disclaimer slide which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images promptly. So let's move to our question first. Question first is the correctly reported answer of the addition of 4.523, 2.3 and 6.24 will have significant figures. Options are 2, 3, 4 and 5. So you have 10 seconds to evaluate and practice this question by yourself. After that, we will solve this question. Okay, so the correctly reported answer of the addition of these three digits have significant figures of 3. Okay, so how? Like solution will be 4.523 plus 2.3 plus 6.24. We will add all these digits and the answer is coming out as 13.063. As 2.3 has least number of decimal places in these three digits, 2.3 has least number of decimal places. That is 1, therefore sum should be reported to one decimal place only. So 2.3 has least number of decimal places, that is 1. Therefore the answer or the sum of these three digits should be reported to one decimal place only, and after rounding off the reported sum will be 13.1, which has three significant figures. The answer will be B, that is 3. Okay, moving to our next question. The A student performs a titration with different burettes and finds titer value of 25.2 ml, 25.25 ml, and 25.0 ml. The number of significant figures in the average titer value is. The options are 1, 2, 3, or 4. So you have 10 seconds to evaluate by yourself and then we will solve this question. Okay, so the answer will be 3. How? The average value will be come out as the sum of these three digits upon 3 divided by 3, which is coming out as 25.15. That is on approximate it will be 25.2 mole, and the number of significant figures in this digit is 3. So answer will be 3. Okay, moving on to our third question. A metal oxide contains 53% metal and carbon dioxide contains 27% carbon. Assuming the law of reciprocal proportions, the percentage of metal in the metal carbide is. Options are listed here: 75%, 25%, 37%, or 66%. You have 10 seconds. Evaluate by yourself, by yourself, and then we will solve the question. Okay, so answer will be 75%. How? The solution is in metal oxide, metal is 53%, which is given. So oxygen will be 47%. Okay, and in CO2, carbon contain carbon is 27%, oxygen is 73%. Okay, 27% is given. So since 73 parts of oxygen combine with 27% of carbon, okay, 27 part of carbon, therefore 47 part of oxygen will combine with, so oxygen, this much oxygen will combine with this much carbon, so this much oxygen will combine with how much carbon, which is coming out as 27 divided by 73 multiplied by 47, that is 17.3838 parts of carbon. Thus metal and carbon will be present in the ratio of 53 ratio 17.38. Hence, if we find out the percentage of metal in the metal carbide, that will be 53 divided by the sum of 53 and 17.38 multiplied by the 100 for the percentage, and it is coming out as 75%. Moving on to our question fourth. The two oxides of metal were found to contain 31.6% and 48% of oxygen, respectively. If the formula of the first is represented by M2O3, then formula of second is. Options are MO3, MO2, M2O, M2O2. So evaluate by yourself. You have 10 seconds to this, and then we will solve this question. Okay, so the answer will be option A. And how? The first oxide is given as M2O3. Here, oxygen is 31.6% and metal is 68.4%. Okay, and in the second oxide, it is given that oxygen is 48%. So the metal will be 52%. Let the second oxide be MOX. So 68.4 gram of metal in first oxide will be equal to 2 atom of M, right? As we can see, 68.4 gram of metal will be equal to 2 atoms of metal. So 52 gram of metal contains how much metal atom? That will be calculated as 2 multiplied by 52 divided by 68.4, and it is coming out as 1.5 atom of metal. And similarly, in oxygen, 31.6 gram of oxygen contains 3 atoms of oxygen. So 48% or 48 gram of oxygen contain how much atoms of oxygen? That will be found out as 3 multiplied by 48 divided by 31.6, which is coming out as 4.5 atoms of oxygen. So ratio of metal to oxygen will be 1.5 ratio 4.5. So it will be 1:3, and thus our formula will be MO3, as we have uh, supposed the number of atoms of oxygen will be X and metal will be 1. So, and the ratio, finally the ratio is coming out as 1:3. So the formula will be MO3. Hence the option E is correct. Okay, moving on to our question fifth. The equivalent weight of H3PO2 when it disproportionates into PH3 and H3PO4 is. Options are 82, 61.5, 16.5, 20.5. You have 10 seconds to evaluate this question by yourself. After that, we will solve this question. Okay, the correct option is C. How? H3PO2 will disproportionate as this. H3PO2 will give you PH3 plus H3PO4. Okay, here phosphorus has +1 oxidation states, and it is going in -3 oxidation state and +5 oxidation states. So molecular weight will be 3 plus 31 plus 32 for oxygen, and total is 66. So equivalent weight will be molecular weight divided by the change in the oxidation number. So 66 divided by 4, which is coming out as 16.5. That's why the correct answer will be C. Moving on to our question 6. 3 gram of an oxide of a metal is converted to chloride completely, and it yielded 5 gram of chloride. The equivalent weight of the metal is. Options are 33.25, 3.325, 12, and 20. You have 10 seconds to solve this question by yourself. After that, we will solve this question. Okay, so the correct option will be A. So as we know, gram equivalent will be equal to weight upon equivalent weight. So gram equivalent of any metal oxide is equal to gram equivalent of any metal chloride. So by exchanging the terms of this formula and putting it in equivalent terms, weight of metal oxide divided by weight of metal chloride will be equal to the sum of equivalent weight of metal and oxide divided by the sum of equivalent weight of metal and chloride. So 3 by 5, which is given, is equals to, let's suppose equivalent weight of metal will be E. So E plus 8, E plus 35.5, where E will be equivalent weight of metal. And so on solving this equation, we are getting our E value, that is 33.25. So option A will be correct. Moving on to our question 7. Sea water contains 65 into 10 to the power minus 3 gram liter inverse of bromide ions. If all the bromide ions are converted to produce bromine Br2, how much seawater is needed to prepare 1 kilogram of bromine molecule Br2? Options are 15.38 liter, 15.38 into 10 to the power 3 liter, 7.69 into 10 to the power 3 liter, 76.9 liter. You have 10 seconds to solve this question by yourself. After that, we will solve this question. So the correct option will be B option. How the bromine ion will get to the bromine molecule like this. So equivalence of bromine ion will be equivalence of bromine molecule. So W by 80 weight upon molecular weight equals to 10 to the power 3 divided by 160 upon 2, which will be equal to 10 to the power 3 gram. So therefore seawater needed 10 to the power 3 divided by 65 into 10 to the power minus 3 liter, which is equals to 15.38 multiplied by 10 to the power 3 liter. So that's why option B will be correct. Moving on to our question 8. 0.376 gram of aluminium reacted with an acid to displace 0.468 liter of H2 measured in standard conditions. Equivalent volume of H2 formed is, so equivalent mass of aluminium is given, that is 9 gram per equivalent, and options are 22.4 liter, 5.6 liter, 11.2 liter or 2.24 liter. You have 10 seconds to solve this question by yourself. After that, we will solve this question. Okay, so the correct option will be C option. We have given that 0.376 gram aluminium will be equal to 0.468 liter of H2, right? So 0.376 divided by 9 equivalent of aluminium will be equal to 0.468 liter of H2. Therefore, 1 equivalent of aluminium will be 11.2 liter of H2. Okay, so option C will be correct. Moving to our question 9. The same amount of a metal combines with 0.200 gram of oxygen and with 3.17 gram of a halogen. Hence, equivalent mass of halogen is. Options are 127 gram, 80 gram, 35.5 gram, 9 gram. You have 10 seconds to solve this question by yourself, and after that we will solve this question. Okay, so the correct option will be A option. So 0.20 gram of oxygen will be equal to the 3.17 gram of halogen as given, and therefore equivalent mass of halogen will be 3.17 divided by 0.20 multiplied by 8. Okay, this will be equal to 127 gram. That is why the option is correct. Moving on to our question 10. If we consider that 1 by 6 in place of 1 by 12 mass of carbon atom is taken to be the relative atomic mass unit, the mass of 1 mole of a substance will, to be a function of the molecular mass of the substance, remain unchanged, increase twofold, or decrease twice. You have 10 seconds to solve this question by yourself. After that, we will solve this question. Okay, so the correct option will be B option. That is, mass of the given amount of a substance is constant quantity, hence it will remain unchanged. Okay. Moving on to our question 11. How many moles of magnesium phosphate, that is Mg3PO4 ka whole twice, will contain 0.25 mole of oxygen atoms? Options are 0.02, 3.125 into 10 to the power minus 2, 1.25 into 10 to the power minus 2, 2.5 into 10 to the power minus 2. You have 10 seconds to solve this question by yourself. After that, we will solve this question. So the correct option will be B option. How? In Mg3PO4 whole twice, 1 mole of oxygen atom are present in 1 mole of Mg3PO4 whole twice. Right? Hence, 0.25 mole of oxygen atom are contained in 1 by 8 multiplied by 0.25, that is 3.125 into 10 to the power minus 2. Okay, moles of magnesium phosphate. So this will be the answer. Moving on to our question 12. Rearrange the following from 1 to 4th in the order of increasing masses and choose the correct answer. Atomic mass of oxygen, copper, and nitrogen is given here. So the first statement is 1 molecule of oxygen, second is 1 molecule of nitrogen, third is 1 into 10 to the power minus 10 gram molecular weight of oxygen, and fourth is 1 into 10 to the power minus 10 gram atomic weight of copper. So we have options listed here. It is given in A option, B option, C option, and D option. Try to solve this question by yourself. You have 10 seconds to do it, and after that we will solve this question. Okay, so the correct answer will be option A. So we have asked that we have to arrange these four terms in increasing masses. Okay, and we have to choose the correct order given in the answer options. So option correct will be A, how that in the first one molecule of O2, the mass will be 32 divided by 6.02 into 10 to the power 23 gram. That is coming out 5.3 into 10 to the power minus 23 gram. Similarly, in second option, it is coming out as 2.3 into 10 to the power minus 23 gram. In the third option, 3.2 into 10 to the power minus 9 gram. And in the fourth option, 6.35 into 10 to the power minus 9 gram. That's why the mass of increasing, the order of increasing mass given in the option A will be correct. That is second, that is the fourth, then the third, then the first, and then the second. This is the order. Okay. Moving on to our question 13. Number of atoms in the following sample of substances is largest in. Options are 4 gram of hydrogen, 70 gram of chlorine, 127 gram of iodine, or 48 gram of magnesium. You have 10 seconds to solve this question by yourself. After that, we will solve this question. Okay. So the correct option will be option A. So the number of atoms will be equal to weight upon atomic weight multiplied by the Avogadro's number into species. So in 4 gram of hydrogen, number of atoms will be 4 by 2 into Na into 2, that is 4 Na. In 71 gram of chlorine, it will be 2 Na of atom. In 127 gram of iodine, it will be 2 Na of atom. In 48 gram of magnesium, it will be 2 Na of atoms. And hence the number of atoms largest is in 4 gram of hydrogen, that is 4 Na. That's why option A is correct. Moving on to our question 14. The total number of electrons present in 18 ml of water is, the density of water is given. The options are 6.02 into 10 to the power 23. B option will be, okay, this is same. C option will be 6.02 into 10 to the power 24. D option will be 6.02 into 10 to the power 25. So let's do it as 10 to the power 26. Okay. Yeah, you have 10 seconds to solve this question by yourself. After that, we will solve this question. Okay, so the correct option will be C option, that is 6.02 into 10 to the power 24 electrons. So how? 18 ml of H2 will be equal to 18 gram of H2, that is 1 mole. And in the 1 mole, 6.02 into 10 to the power 23 molecules are present. So in 1 atom of water, 10 electrons are present. Okay, therefore, electrons in 1 mole of O2 will be 8 plus 2 multiplied by 6.02 into 10 to the power 23 electrons. It is coming out as 6.02 into 10 to the power 24 electrons. So, correct option will be C. Moving on to our question 15. The weight of 10 to the power 22 molecules of USO4.5H2 is, options are 41.59 gram, 415.9 gram, 4.159 gram, or none of these. You have 10 seconds to solve this question by yourself. After that, we will solve this question. Okay, so the correct option will be C. Since 6.02 into 10 to the power 23 molecules of CuSO4.5H2 will be equal to 63.5 plus 32 plus 64 plus 90, which will be equal to 249.5 gram. Therefore, 1 into 10 to the power 22 molecule of CuSO4.5H2 will be equal to 249.5 divided by 6.02 into 10 to the power 23 multiplied by 10 to the power 22, and which is coming out as 4.15 gram. Hence, option C is correct. Moving on to our question 16. The number of moles of NH4 whole twice SO4 Fe2SO4 whole thrice dot 24H2 formed from a sample containing 0.0056 gram of Fe is. So we have to find out the number of moles. The options are listed here: 10 to the power minus 4 mole, 0.5 into 10 to the power minus 4 mole, 2 into 10 to the power minus 4 mole, 0.33 into 10 to the power minus 4 mole. You have 10 seconds to solve this question by yourself. After that, we will solve this question. Okay, so the correct option will be B option. Number of moles of Fe will be given mass upon molar mass, that is 10 to the power minus 4 mole. 2 moles of iron is present in 1 mole of this compound. Therefore, 10 to the power minus 4 mole of Fe is present in 10 to the power minus 4 divided by 2 mole. That is 0.5 into 10 to the power minus 4 mole. Hence, option B will be correct. Moving to our question 17. If 10 to the power 21 molecules are removed from 200 milligram of CO2, the number of moles of CO2 left are, options are listed here: 2.88 into 10 to the power minus 3, to 28.8 into 10 to the power minus 3, 0.288 into 10 to the power minus 3, 1.66 into 10 to the power minus 2. You have 10 seconds to solve this question. After that, we will solve this question. Okay, so the correct option will be option A. How the solution is: 200 milligram of CO2 will be equal to 0.2 gram. Okay, so 0.2 divided by 44 mole is equal to 0.00454 mole, which is which can be written in this way: 4.54 into 10 to the power minus 3 mole. So 10 to the power 21 molecules of CO2 will contain 10 to the power 21 divided by 6.02 into 10 to the power 23, which is coming out as 1.66 into 10 to the power minus 3 mole. So the number of moles left will be 4.54 minus 1.66 into 10 to the power minus 3, that is 2.88 into 10 to the power minus 4. So option E will be correct option. Moving on to our question number 18. Medical experts generally consider a level of 30 microgram lead per dl of blood to pose a significant health risk, and 1 dl will be equal to 0.1 liter. Express this lead level as the number of lead atoms per centimeter cubic blood. So lead atomic mass is given as 207. Atomic Yeah. So options are listed here. 8.72 into 10 to the power 14, 8.72 into 10 to the power 15, 8.72 into 10 to the power 13, 8.72 into 10 to the power 16. You have 10 seconds to solve this question by yourself. After that, we will solve this question. Okay, so the correct answer will be A. So the solution will be 0.1 liter will be equal to 100 ml lead, which is equal to 30 milligram. Okay, so 100 ml has lead equal to 30 milligram, which is equal to 30 into 10 to the power minus 6 grams. So, uh, 30 into 10 to the power minus 6 divided by 207 mole of lead, which is equals to 30 into 10 to the power minus 6 upon 207 multiplied by 6.02 into 10 to the power 23, that is Avogadro's number, lead atoms. Okay, so number of atoms per centimeter cubic lead will be 30 into 10 to the power minus 6 multiplied by Avogadro number divided by 207 multiplied by 100. This will be equal to 8.72 into 10 to the power 40. So this will be our solution, and hence the option A will be correct option. Moving to our question 19. Which of the following pairs of gases contains the same number of molecules? Options are 16 gram of O2 and 14 gram of N2, 8 gram of O2 and 22 gram of CO2, 28 gram of N2 and 22 gram of CO2, 32 gram of O2 and 32 gram of N2. You have 10 seconds to solve this question by yourself. After that, we will solve this question. Okay, so the correct answer will be option A. How? Let's see. 16 gram of O2 will be equal to 16 divided by molar mass, that is 32. That is equal to 0.5 mole. That is Na by 2 molecules. So 14 gram of N2 will be equal to 14 divided by 28. That is 0.5 mole. That is Na by 2 molecules. Okay, so hence option A will be correct option. Moving on to our question number 20. The number of hydrogen atoms present in 25.6 gram of sucrose, which has a molar mass of 342.3 gram, is. So options are listed here. 22 into 10 to the power 23, 9.91 into 10 to the power 23, 11.11 into 10 to the power 23, 44 into 10 to the power 23. You have 10 seconds to solve this question by yourself. After that, we will solve the question. Okay, so the correct option will be option B. How? The moles of sucrose will be equal to given mass upon the molar mass, which is 0.0747 mole. The number of atoms in 1 mole of sucrose will be 22 into 10 to the power into 6.023 into 10 to the power 23. That is Avogadro's number. So number of hydrogen atoms in 0.747, that is given mole of sucrose, will be 22 multiplied by Avogadro's number multiplied by 0.747, which is coming out as 9.9 into 10 to the power 23. Hence, option B is the correct option. Moving on to our question number 21. The most abundant element by mass in the body of a healthy human adult are oxygen, that is 61.4%, carbon, that is 22.9%, hydrogen, that is 10%, and nitrogen, that is 2.6%. The weight which a 75 kg person would gain if all hydrogen atoms are replaced by deuterium atoms is. So here the hydrogen has molar mass, atomic mass as 2. So options are 15 kg, 37.5 kg, 7.5 kg, or 10 kg. You have 10 seconds to solve this question by yourself. After that, we will solve this question. Okay, so the correct answer will be option C. How? Given abundance of elements by mass, oxygen is by mass for oxygen will be 61.4%, for carbon 22.9%, for hydrogen 10%. So total weight of person is given as 75 kg. Mass due to hydrogen atom will be 75 multiplied by 10 multiplied by 1 divided by 100, that is 7.5 kg. And hydrogen atoms are replaced by deuterium atoms. So mass due to deuterium hydrogen atom will be 7.5 multiplied by 2, that is 15 kg. Therefore, mass gained by the person will be 15 minus 7.5, that is the initial weight, which is coming out as 7.5 kg. Hence, the option C will be the correct answer. Moving on to our question number 22. A gaseous hydrocarbon gives upon combustion 0.72 gram of water and 3.08 gram of CO2. The empirical formula of the hydrocarbon is, options are C2H4, C3H4, C6H5 or C7H8. You have 10 seconds to solve this question by yourself. After that, we will solve this question. Okay, so the correct option will be D option. How? 18 gram of H2O contains 2 gram of hydrogen. Therefore, 0.72 gram of hydrogen contains 0.08 gram of hydrogen. Similarly, 44 gram of CO2 contains 12 gram of carbon. Therefore, 3.08 gram of CO2 contains 0.84 gram of carbon. Therefore, C ratio H hydrogen will be 0.84 is to divide by 12 is to 0.08 divided by 1. These are the atomic masses of carbon and hydrogen respectively. And this is coming out as 7:8. So the empirical formula will be C7H8 of the hydrocarbon. So the option D will be correct. Moving on to our question number 23. A 0.2075 gram sample of an oxide of cobalt on analysis was found to contain 0.1475 gram cobalt. The empirical formula of the oxide is, the options are COO2, CO2O3, COO, CO4O6. You have 10 seconds to solve this question by yourself. After that, we will solve the question. Okay, so the correct option will be option B. How? The weight of oxygen in sample is 0.2075 minus 0.1475, which will be 0.06 gram. So moles of cobalt will be given mass upon the molecular mass, that is 0.0025. Similarly, moles of oxygen will be a given mass upon molecular mass, that is 0.0037. So simplest ratio of cobalt will be the moles of cobalt divided by the smallest mole coming out, that is 0.0025, which is equal to 1. Similarly, simplest ratio of oxygen will be 0.0037 divided by the smallest moles of the element coming out, that is 0.0025, which is coming out as 1.5. So the ratio of cobalt to oxide will be 1:1.5, that is 2:3. So the formula of cobalt oxide will be CO2O3. Hence, option B will be the correct option. Moving to question number 24. At 300 Kelvin and 1 atmosphere, 15 ml of a gaseous hydrocarbon requires 375 ml air containing 20% oxygen by volume for complete combustion. After combustion, the gases occupy 330 ml. Assuming that the water formed is in liquid form and the volumes were measured at the same temperature and pressure, the formula of the hydrocarbon is, options are C3H8, C4H8, C4H10 or C3H6. You have 10 seconds to solve this question by yourself. After that, we will solve this question. Okay, so the correct option will be option A. How? let's write the general equation of the combustion reaction, that is CXHY plus X plus Y by 4 of O2 will give you X CO2 and Y by 2 H2. So before combustion, the O2 used is 20% of 375, which is coming out as 75 milliliter. After combustion, the inert pure of air, that is 80% of 375, that is 300 ml. So total volume of gases will be equal to CO2 plus inert pair of air, that is 330 will be equal to 15x plus 300. So from this equation, x is coming out as 2, and we are balancing the O2 used to the initial hydrocarbon volume, that is x plus y by 4 divided by 1 will be equal to 75 by 11, or you can say x plus y by 4 will be equal to 5. From here, x is, on putting x value equal to 2, the y is coming out as 12. So it is making the formula as C2H12. This C2H12 is not an existing compound, but the value of x equals to 3 and y equals to 8 is satisfying the equation x plus y by 4 equals to 5. Here the equation will be x plus y by 4, okay, equals to 5. That's why the empirical formula of the compound will be C3H8. Hence option A will be correct. Okay, so moving to our question number 25. The ratio of mass percent of carbon and hydrogen of an organic compound CXHYOZ is 6:1. If one molecule of the above compound CXHYOZ contains half as much oxygen as required to burn one molecule of compound CXHY completely to CO2 and H2O, the empirical formula of compound CXHYOZ is. Options are given as C3H6O3, C2H4O, C3H4O2, C2H4O3. You have 10 seconds to solve this question by yourself. After that, we will solve this question. Okay, so the correct answer will be option D. How? So we can calculate the simplest whole number ratio for carbon and hydrogen from the data that is given here. So element carbon and hydrogen, the relative mass is 6 and 1. The molar mass is 12 and 1. The relative mole will be 6 divided by 12, that is 0.5, and 1 by 1, that is 1. So simplest whole number ratio will be 0.5 divided by the smallest relative mole, that is 0.5, that is equals to 1. And for hydrogen, 1 divided by 0.5, that is 2. Now the given quantity of oxygen is half of the quantity required to burn one molecule of compound CXHY completely to CO2 and H2. So consider this combustion general equation. Number of oxygen atom required will be 2 into X plus Y by 4. 2 atoms of oxygen are required. So it is written as 2x plus y by 2, right? So z is given as half of 2x plus y by 2, right? Z is given as half of the atom which is used in the reaction of oxygen. So that is 2x plus 2 by 4. Here we consider x and y as simplest ratio for carbon and hydrogen. So now putting the values of x and y in the above equation, z will be equal to x plus y by 4, that is equals to 1 plus 2 by 4, that is 1.5. Thus, the simplest ratio figures for x, y, and z are x will be 1, y will be 2, and z will be 1.5. Now put these values in the formula given, that is CXHYOZ will be C1H2O 1.5. So empirical formula will be C1H2O 1.5 multiplied by 2, that is C2H4O3, because this doesn't make any sense, right? So this is a empirical formula which is coming out as answer. Okay. Okay, thank you.